So this lesson is about the solubility. So we start with the S words. So solute is essentially the solid that dissolves. So you would have typically salt plus water equals salt solution. Now the solute is going to be the salt. That is your solute. So it's the solid that's going to dissolve. Your water is going to be the liquid that dissolves the solute. So it's going to be called a solvent. And the product is a solution. So when something dissolves, it forms a solution. So the solid particles, they dissolve by spreading out in between the gaps of the water particles. And we have a solution. Now, a soluble salt is one that dissolves in a solvent, and insoluble means it doesn't dissolve. Very basic things. The other thing you have to know is what the term saturated solution means. And that is defined the point at which saturation is the point at which normal solid can dissolve. So a solution which contains the maximum amount of solute that can be dissolved at the given volume / temperature. Because when you change the amount of volume, the amount of liquid, the amount of solvent, you can actually dissolve more. And if you heat something up, it can actually dissolve more. That's because a liquid, when you heat it up, the particles will vibrate more and move more, leaving more gaps between them, resulting in more being able to dissolve. Think about a hot cup of tea versus a cold cup of tea. The hot cup of tea would be able to dissolve more sugar than the cold cup of tea. With these basic definitions out of the way, we do need to look at one more, and that is what the word solubility actually means. It's stated in your syllabus in bold. So solubility is the amount in grams of solute that can dissolve in 100 grams of solvent. So everything is, when something is given a solubility number, it might be saying 60 grams. That means 60 grams can dissolve in 100 grams of solvent. As a result of this, you'll need to be able to interpret curves called solubility curves. So I'm going to show you how to do that now with a few examples and attach the worksheet. The example I'm going to use is right here. No, 1 second. Solubility curves. Here it is. So if you look at it across this way, these are the solubility curves plotted. So you see grams of solid per 100 grams of water. So in 100 grams of water, for example, if we look at sodium nitrate, we can see that at 0 degrees, about 72 grams can dissolve. Whereas potassium iodide is more soluble because at 0 degrees, 128 grams can dissolve. So if we look at some of the questions just to practice, how much Ki will dissolve in 100 grams at 20 degrees? So Ki is here. At 20 degrees, all you do, you show the examiner that you're going up. So at 20, you go up and across, and you get roughly 145 or 144 grams. Now be careful, if the examiner asks you for how much would dissolve in 50 grams of water at that temperature, you have to halve it. Okay, if they ask you in 20 grams of water, you would divide it by 5. So always read the axes. The other style of question you can get, if we look up at the questions, what temperature is necessary for 40 grams of potassium chloride to dissolve in 100 grams of water. So for 40 grams of KCl, you would go this way, 40. You would go across to the KCl and down. So you get about 48 degrees. So once again, you go across and down. Now, how the question may be something such as the following. If 70 grams of sodium nitrate dissolves in 100 grams of water at 30 degrees, will the solution be unsaturated, saturated, or supersaturated? Now, I didn't deal with the term supersaturated because it wasn't on your syllabus, but supersaturated means that you've put more solute or solid than can actually be dissolved. So saturated is the maximum amount. Supersaturated means you've put too much, so it's no longer dissolving. It's going to stick on the bottom. Unsaturated obviously means that you can accept more. So back to the question, if 70 grams of this was to dissolve at 30 degrees, what happens? Well, let's have a look. So make it a bit smaller, 70 grams. Was it sodium nitrate? Okay, so we look here, 70 grams is here. But the temperature stated was, once again, just to double check, the temperature stated was 30 degrees. So at 30 degrees, if you look, you can go up and across. You can actually dissolve up to 98 grams. So if we only have 70 grams dissolved at 30 degrees, the solution will be unsaturated because we have less than the required amount. If, on the other hand, I change the question and say, what happens if I have 120 grams of sodium nitrate in 30 degrees? Then you can clearly see that 120 grams is up here. So that means that this 120 is here. And at 30 degrees, the maximum is 98. So that means the difference between these two, which is 22 grams, that's the amount of grams, that's the mass of grams that will be on the bottom of the beaker, because the solution is actually supersaturated. It has too much solid. So in order to actually dissolve the 120 grams, you would need to heat it up all the way to about 55 degrees. So it's all about reading things off the graph and seeing which one's more soluble. So for example, at 80 degrees, which one's more soluble, KCl or NaCl? Well, you can clearly see that if you go up, NaCl is more soluble at 80 degrees. And that's how these work. They're not too difficult. You may have to plot one, but at the end of the day, it's not that difficult to solve. So that brings that lesson to an end. And the next lesson will be elements, compounds, and mixtures, and then separating techniques. See you then.